Welcome. Let's review chemical nomenclature. So when it comes time to name a chemical compound, really what falls into one of two categories. It's either going to be an ionic compound or it's going to be a covalent compound or an acid. And so the question is, how do you know what's what? Well, the question to ask yourself is, does it have a metal or a polyatomic cation present? And if the answer is yes, it does, then that means you have an ionic compound. If the answer is no, it does not, then this is going to be either a covalent compound or it's going to be an acid. And so you'll learn to recognize those acids by our convention of writing hydrogen out front, but it's going to fall into one of those two categories. So once you're ready to name something, the question was, does it have a metal or polyatomic cation? If the answer is yes, then you need to ask yourself, does it have a transition or post-transition metal, something that can have variable charge? And then from there, if the answer is no, then you just have the most basic name. You're going to give your metal's name unchanged for that cation. And then the non-metal, you're going to take that element's base name and you're going to add an IDE ending. So for example, if you have CaCl2, this is calcium chloride. If you do have a transition or post-transition metal, something with a variable charge in it, then you just need to include what the charge is with Roman numerals. And so your name is simply the metal, and then here the charge using those Roman numerals right there. And then again your non-metal with that IDE ending. If you don't have a metal or a polyatomic cation, then you have either a covalent compound or you have an acid. And so how do you decide if you have an acid? Well, does it start with a hydrogen? If the answer is yes, you have an acid. But acids are really only acids when they're in aqueous solution. So if it's a gas, then it's not going to act as an acid and you're going to name it just as a covalent compound because that's what it is. And so then it will name as the same as if it didn't have a hydrogen. And this is where you're going to use your prefixes to indicate subscripts. So for example, if you had N2O4, this is dinitrogen tetraoxide. If it's not a gas, if it is an aqueous solution, then you do have an acid. And so you're going to name as an acid, and we are going to go through those rules on the next slide. Okay, so let's talk about naming acids. Acids fall into two categories. You have binary acids and you have oxyacids. So binary, that prefix bi means two, so you only have two elements. This is going to be hydrogen and one other element. So things like chlorine, bromine, HCl, HBr. And the naming rules for acids is you're going to have the prefix hydro, you're going to have your element core name, and then you're going to have an ic ending and tack the word acid on. So let's say, for example, you have HBr. This is going to be hydrobromic acid. So you've got your hydro prefix, your ic ending, and then the word acid at the end. Oxyacids obviously contain oxygen, and these are polyatomic ions that have hydrogens attached to balance the charge, enough hydrogens to balance the charge. And so since they have a polyatomic ion at their core, their name depends upon that polyatomic ion. And so what you're going to do is you're going to look at the name of that polyatomic ion, and that polyatomic ion might have an ending of ate or might have an ending of ite. And that's going to determine your acid name. So if the polyatomic ion name ends in ate, then your acid is an ic acid, no prefix. If your polyatomic ion's name ends in ite, this is an us acid. So for example, if I have HiO3, IO3 is the polyatomic ion iodate, and so this is going to be iodic acid. Please note the difference between binary acids and oxyacids is that oxyacids don't have that hydro prefix. Okay, folks, since these acids are based on polyatomic ions, you're going to have to know some polyatomic ions. Here are the 8 that I want you to have memorized: nitrate, sulfate, carbonate, phosphate, acetate, hydroxide, ammonium, and chlorate. Please note that chlorates, iodate, and bromate all have the same, just switching out those halogens, but these are the 8 you need to have memorized. Make flashcards. Last thing I'm going to do is we're going to work some naming examples. Okay, so as you take a look at these, again, you need to start by asking yourself, do you have a metal present? If I look over here at AlCl3, the answer is yeah, I've got aluminum. And so aluminum is not a transition metal. I don't need any Roman numerals. This is just aluminum chloride. HNO3, ooh, I've got a hydrogen. Okay, so here don't have a metal. I don't have a transition metal or I have a hydrogen though. So this is gonna tell me I have an acid. And so this NO3 is nitrate. And so this is nitric acid. Next one down, N2O4, no metals. So this is going to be a covalent compound. I don't have hydrogen. I'm just going to name it using prefixes. So this is dinitrogen tetraoxide. Last one in this column, FeOH3. Iron is a metal and it is a transition metal, so it can have variable charges. So I'm going to figure out the charge on that iron in order to write its name. Hydroxide always has a charge of -1. Memorize that, please. Since there's 3 of those, I have overall a charge of -3. And since any compound has to have equal number of positive and negative charges, I know that the charge on the iron then has to be a +3, which means that this name is iron, Roman numeral 3, hydroxide. Going from name to formula, you need to remember to cancel your charges. So if I've got sodium carbonate, sodium is Na, carbonate is CO3, but don't forget the charges. Sodium is a +1 cation, carbonate has a -2 charge. In order to have equal positive and negative charges in an overall neutral compound, I'm going to need 2 of the sodiums. Phosphorus trichloride, I see a prefix in there, so I know I don't have to worry about anything other than what those prefixes tell me. Phosphorus is P, chloride is Cl, and there's 3 of those since it is trichloride. Manganese 4 oxide, okay, so manganese is Mn. That Roman numeral 4 means its charge is +4. Oxide tells me I've got oxygen, and I know its charge is -2. In order to have an overall neutral compound, therefore, I'll need 2 oxygens. Lastly, sulfurous acid. Okay, that OUS is telling me that this is coming from an ite polyatomic ion. This is sulfite. Sulfite is SO3, and it has a 2- charge. In order to make it an acid, I just add enough hydrogens in order to cancel the charge. And so I need 2 hydrogens, and this is H2SO3. Ta-da! Naming just takes some practice. As long as you remember those basic rules, you're going to be in good shape.